Alright everybody, welcome back. In this video we're going to look at simplifying some expressions using Euler's formula. If you remember from the last video, Euler's formula is that e to the ix is equal to the cosine of x plus I times the sine of x. And we're going to utilize that in each of these simplifications. We first look here at e to the 2I theta and realize that we can write this as e to the I times 2 theta. And what that means then is we're just going to take 2 theta and put that in this Euler's formula everywhere where there's an x. And so, to write e to the 2I theta plus e to the negative 2I theta, we're going to have cosine of 2 theta plus I sine of 2 theta, and that's equal to e to the 2I theta, and we're going to add to that cosine of negative 2 theta plus I sine of negative 2 theta. And in order to simplify this further, we need to think about what happens in our unit circles with various values of angles and the sort. If we think about our unit circle, and suppose we have an angle 2 theta here, if we think about the angle negative 2 theta, sorry, my writing's a little cramped up here. The cosine of negative 2 theta is the same as the cosine of 2 theta because it's this horizontal distance in both of those, and those are identical. Whereas the sine of 2 theta and the sine of negative 2 theta, they're opposites of one another. And so what I can do is I can simplify this expression. I've got cosine of 2 theta plus I sine of 2 theta. But the cosine of negative 2 theta is the same as the cosine of 2 theta. So I'm going to replace that with a cosine of 2 theta. And the sine of negative 2 theta is the opposite of the sine of 2 theta, so this becomes minus I sine of 2 theta. Should probably group those there. Alright, and now simplifying, we see that we have an I sine of 2 theta and a negative I sine of 2 theta. They're just going to add together to make 0. And the cosines of 2 theta will add together. And so, the value of e to the 2I theta plus e to the negative 2I theta is just 2 cosine of 2 theta. Alright, let's go ahead and do the next one. E to the 7I theta minus e to the negative 7I theta. E to the 7I theta is just going to be cosine of 7 theta plus I sine of 7 theta. And then we are subtracting away cosine of negative 7 theta plus I sine of negative 7 theta. Using the same argument that we used in the last one based off of the unit circle, we can replace cosine of negative 7 theta with cosine of 7 theta, and we can replace sine of negative 7 theta with negative sine of 7 theta. And now we can simplify from here. Since we're doing subtraction, the cosine of 7 thetas, subtract to make nothing, and we've got I sine of 7 theta minus negative I sine of 7 theta, and those combine to make 2I sine of 7 theta. Let's see what else we got here. Part C. Oh, that's the last one. All right. So we've got e to the 5I theta scroll this down here and hopefully neaten up my writing a little bit. We've got e to the 5I theta minus e to the negative 5I theta, all of that over 2I. And so that's going to be cosine of 5 theta plus I sine of 5 theta minus cosine of negative 5 theta plus I sine of negative 5 theta, all over 2I, which is going to be equal to, again, we're going to make those unit circle replacements. And cosine of negative 5 theta is equal to cosine of 5 theta, whereas sine of negative 5 theta is equal to negative sine of 5 theta. We still have all of that over 2I. And then simplifying these, we end up with 2I sine of 5 theta all over 2I. And so the value of this expression is sine of 5 theta. All right. That's the last example from this lesson, so we'll end our video here. See you guys next time. Have a great rest of your day.